First means go all the way till you get x equals as your answer. All right. Okay, solve 3 parentheses 2x plus 1 parentheses squared equals 24. Now, this is a similar question to your quiz. A bunch of you tried the quadratic formula on it. Let me show you a different way to do that. Okay? Rather than use the quadratic formula, which makes really, really big numbers, let's get some of these numbers down a little smaller. Let's get rid of the 3. How can we do that? Not distribute. Okay? I can't distribute here. I can't distribute a square. I can't distribute a 3. Squares block you from distributing. Instead, I can get rid of the 3 by dividing. All right, so if we divide by 3 on both sides, we'll end up with 2x plus 1 quantity squared equals 8. The next thing we want to do is get rid of the square. And again, you can't distribute a square. Okay, I can't distribute a square. What I can do is use a square root. Okay, I cannot distribute a square, but I can do a square root. And so what I'm going to do is use a square root around 2x plus 1 squared and a square root around the 8. Now on the left side, the square root cancels out the square and they disappear entirely and you're left with 2x plus 1. On the right side, because there's a square root there that will not cancel out, you got to have a plus minus. There needs to be a plus minus in front of every radical. Also, the square root of 8 can be simplified. How? Okay, 4 and 2, so it'll become 2 rad 2. But if you don't have the plus minus, it's going to be half credit for the problem automatically because you're going to miss half of the answers. All right, now we still need to get x equals. We are not finished. We need to push through, so we have to keep doing things to both sides. The next step would be to do what? Subtract 1. It's usually common practice to put that subtract 1 in front of your plus minus. So it's negative 1 plus or minus 2 rad 2. And then my final step would be to divide by 2. So my answer would be negative 1 plus or minus 2 rad 2 over the number 2. I do not cancel out the 2's. I do not reduce the 2's. The plus or minus blocks me from doing that. And I stop. Waiting.
Don't we do that on the quadratic formula?
Only if you've separated it. Okay, if you separate and do a common denominator, put the plus or minus between the two problems, then you're allowed to reduce these two 2's only.
So
Okay?
can we do that?
You may.
Okay.
You may. But you have to, there still has to be a 2 underneath a negative 1. So if you wanted to do that, then usually you would only do that if you could reduce both of them. But if you want to do it, you can. It's not wrong. Like that. Okay? All right, so there's one use of the plus minus. All right, here is the second use of the plus minus, and it has to do with absolute values. So solve 2 on the outside of an absolute value, x minus 4, and the absolute value equals 16. So to solve always means to get rid of things. So what we want to get rid of first is what? The 2. That leaves me with x minus 4 equals 8. The next thing I want to get rid of is the absolute value. And you can use a plus or minus in place of the absolute value. Not on the same side, but on the opposite side, like this.
Oh, I love that.
Okay? So that gets rid of the absolute value so you don't have to worry about that anymore. You still need it to be x by itself though, so the last thing we would do to both sides is what? Add 4, so it's going to go in front, 4 plus or minus 8. Which means 4 plus 8 will be one answer, and 4 minus 8 will be another answer. So my two answers are x equals 12 and negative 4. Okay, but if you forget the plus minus, you've forgotten half of the answers, and so then you'll only get half credit. Okay, that plus minus. So in front of every radical and in place of every absolute value. Okay, let's try another one. All right, how about 3 absolute value x plus 1 less than 12? Okay, what's the difference automatically that maybe your little spidey sense is picking up from between the problem we just did and this one? The inequality. Okay, the inequality, which means no different really in the math except that your answer is going to be on a number line. Okay, all right, so yes, divide by 3. So x plus 1 absolute value less than 4. Now we want to get rid of the absolute value. So we're going to put the plus minus by the 4. And because this is an inequality, we're going to separate the positive and the negative from each other. And it's going to look like this. The negative 4 is going to go on the left because it's the smaller one. And then we'll have an inequality that leads us to x plus 1. And then we'll have an inequality that ends at positive 4. Okay, so with inequalities, you'll take the negative part and put it on the left, and the positive part and put it on the right. Okay? Then we still need to get x by itself. So what do we do to the middle? Subtract 1. If we subtract it in the middle, we got to subtract it on each side. So I'm going to get negative 5 less than x less than 3. And the inequality should get graphed on a number line. And so I'll go to negative 5. I like open circles, so I'm going to put an open circle. If you like the parentheses, you can use the parentheses. And then I'll go to 3 and put an open circle. And then we'll shade in between. You can also write that in interval notation. I showed you that the other day, where negative 5 is the beginning, comma 3 at the end. And since they're both open circles, we put parentheses. Can you wait till we're done? Or is it, that would probably be better. All right, any questions about that? All right, so each time I'm going to show you a new example that has a little twist. So first we started with the square root that had the plus minus. Then we started with the absolute value that had the plus minus. Then we did an absolute value that has a plus minus plus an inequality. So now I'm just going to add something else to it. Carter. 4, absolute value, 3x minus 2, absolute value, greater than or equal to 20. All right, let's see what we can do with that. All right, so what do you notice that's different about this one? Has the equal to, what else? It's facing the other way. Okay, the inequality is facing the other direction. Oh, and the 3, yep, 3 is there too. Okay, let's just work towards getting x by itself. First step, divide by 4. 3x minus 2, greater than or equal to 5. Next step is to remove the absolute value and replace it with a plus or minus 5. The third step is to bring the negative over to the left side. Keep your inequality going in the same direction. Don't change it around. 3x minus 2, and then the positive 5 would be on that side. Add 2 to everything. In the middle, on the left, and on the right. We end up with negative 3 less than or equal to 3x. Or excuse me, greater than or equal to 3x, greater than or equal to 7. And then you divide by 3. So negative 1 greater than or equal to x greater than or equal to 7/3. We want to graph this on our number line. Negative 1 and then 7/3 is between 2 and 3. Now these are closed circles because of the equal to. Now we got to talk about the shading. Did you learn in Algebra 2 about great or? Did Miss Price or Miss Cowley ever talk to you about the or of great or? When it's greater, like this is, -1 is greater than x, which is greater than 7/3, the arrows go in the opposite direction. Okay, greater than. So greater than has to go out to the right. That's greater. But it also has to go out to the left because you can be greater in a negative sense as well. It is not between. It is not less. Okay, so anything when the arrows are going, the inequalities are going that way as greater, then the arrows are going opposite as well. And if you want to write that in interval notation, -1 and it stops with a bracket, and 7/3 where it starts with the bracket, oops, 4, and then -infinity is the end of the arrow, and +infinity is the end of the arrow, and those both get parentheses because infinity could never have brackets, because you could never be equal to infinity. It's impossible to ever get there. So that's how you write that in inequality, in interval notation with the or. All right, I feel like we have a lot of examples today, but I have 2 more things. Each time I'm going to show you something that there's going to be something new and different. All of these show up somewhere in your homework, so I'm going to try and make sure I show you one of everything. All right, I'm sure you'll pick up on what's different about this right away. Okay, this time we have a square, not an absolute value. Okay, how do we get rid of a square? Can't square root it. We can only square root if it's in parentheses. That was the first question. Yes, factor with what method? Star. There we go. All right, that's the only way to get rid of the square, is to factor with star. So -12 on the top and -1 on the bottom. So that's going to be 3 and -4. Okay, so our factors are going to be x squared plus 3x minus 4x minus 12. Split it down the center. Factor out x and x plus 3. Factor out -4 and x plus 3. Notice that the x plus 3 matches. X minus 4 is the other factor. And because we are solving, we don't stop here. We set them equal to 0. So x is -3 and x is 4. And because this is an inequality, we don't stop here. What do we do next? Because it's inequality.
Oh,
You draw a number line. Every inequality has to be graphed on a number line. All right, on the number line, we'll find -3. We'll find +4. We will put open circles because the inequality did not include it. And then we have to shade. Then the question is always, do I shade in the middle or do I shade the 2 ends? It's less. And so less would be in the center. Okay? How else can we remember that? Less is smaller, right? You got to think smaller space. Which arrows would be longer? Okay? The greater arrows are the ones that go to the infinities. Those are the greater ones. Even going to -infinity is a longer arrow. Okay, the less is the smallest, and so this is the smallest section. What that means is that any number chosen in that region would work as a test subject back in the original equation. Any number between -3 and +4, if you plugged it into the test subject as a test subject back up into the original equation, it will always be less than 0. Okay, there. Yeah, Michael.
Well, never.
Okay. All right, I have one more for you. All right, last one. Solve. 2x cubed plus 3x squared greater than or equal to 20x. All right, we do have this. All right, first of all, let's think that the problem before had a square and had how many answers? 2. This problem is a cube, which will have how many spots on the number line? 3. Okay, there need to be 3 answers on the number line. But what do I have to do first? I do. I need to make sure it's equal to 0. So 2x to the third plus 3x to the second minus 20x. And that'll be greater than or equal to 0. And hopefully, we know we need to solve it with factoring, but we recognize what kind of factoring needs to be the first type. The GCF. What do they have in common? Okay, GCF is x. That leaves me with 2x squared plus 3x minus 20. That can be solved with the star. Negative 40 and 3. 8 and 5 make that work, where the 8 is positive and the 5 is negative. So that'll give me 2x squared plus 8x minus 5x minus 20, which I'll split. 2x is common, leaving me with x plus 4. Negative 5 is common, leaving me with x plus 4. So x plus 4 is one of the solutions. 2x minus 5 is one of the solutions, but don't forget there was a third solution. And the third solution was the x from the GCF, so I'm going to bring that down, and all of those need to get set equal to 0, which give me 3 complete answers. All 3 need to get put on the number line. Zero, 1, 2, 3, 5 halves is right in the middle. And 1, 2, 3, negative 4. All right, these are closed circles because the inequality was closed to begin with. All right, now we got to decide about shading. This is a greater than problem. Greater than always has to go off to the right because it's greater. And then you got to leave a blank section behind it, and the next section behind that would get shaded. Do you understand that it's like in every other thing?
Yes, actually.
Okay. I mean, you can't have 2 shaded ones. There has to be a gap in between. And so in this one, because there were 3 dots, we ended up not going all the way to negative infinity like we did the last time. The last time we went both directions. Okay. If it had been a less than, then we would have shaded, yeah, if it had been less than, we would have shaded one that way and then in between. That would have been the less than portion of it. All right, any questions?